This is the Sony TC-K96R cassette deck from 1978. It was a top-of-the-line deck back in its day. I've had it for about 10 years. It was one of my first intentional vintage stereo purchases. It looked great and was listed as working, which was technically true, but only in the way that a rowboat would work for a transatlantic ocean crossing. Semantically correct, but just really catastrophically bad at the job. This deck's eaten tapes for as long as I've had it, but its main issue has always been just that it sounds absolutely terrible. And not in a some tape decks sound better than others kind of way either. There was always clearly something wrong with it. Just a lot of distortion in the sound, and initially a really low level in one channel. My guess is that it had been sitting in a harsh environment like an attic or garage for decades already, and some of the electronic and maybe even mechanical components had gotten crusty and drifted way out of spec. Possibly a lot of them. It sounded kind of like a tin can telephone. I replaced a few transistors and did some basic servicing when I got it, but I really didn't know what I was doing at the time, and I wasn't able to get it back to an acceptable state. It did get better, but not enough to make it enjoyable to listen to. So it sat again, mostly in my living room, where it served as a constant reminder of my failure, stuck in the back of my mind for years. I always knew I'd revisit it when the day came that I thought I had the skills and knowledge to do so. Well, that day is today. I now have the absolute bare minimum skills and knowledge, or at least I think I do. I'm filming this intro about midway through the process, probably about where I'm going to end part 1. So to give you a little preview, there's definitely more blood, sweat, and tears involved here than I thought there would be, and I knew there would be some. I hadn't planned on this being a multi-part video. But this thing was, and maybe still is, in a highly fragile state. New things will break during this process. I know that YouTube's algorithm will decide to show this to people who will question everything I do in this video. But just remember a couple of things. First, this deck has been sitting for about 30 years total now, and then suddenly been subjected to heavy use. Literally anything on it could break now that it's being used again. It's not all just about belts or capacitors. Second, this isn't my first rodeo at this point, and sometimes what seems like absolute confusion is really just part of my process. Trust the process. After the break, I'll give you a little backstory on the features of this deck so you both have an idea of what we're looking at here, and also why I'm bothering to put so much work into a seemingly random piece of stereo equipment. I do also want to say that this is my hobby, and while I've spent a chunk of time and money getting this thing to work right, this is my entertainment. It's what I do for fun. The process is the point, and I'm actually enjoying this. I hope you enjoyed part 1. And I hope you stick around, or come back, for part 2. And maybe even part 3. First, let's take a look at some of the features of this cassette deck. Helpfully, Sony created an entire sales brochure just for this deck. The brochure shows the deck with no wood side panels and a solid metal top without vents. I've never seen the deck in this configuration, but maybe it was a later revision or something. I much prefer it with the wood panels. Everything's better with wood.
Wood, Jerry. Wood. Wood is good.
This deck has doubly...
You don't do heavy metal in doubly, you know. I mean,
In what?
Oh, that's doubly convenient auto reverse. It was a very early auto reverse deck with a rotating head. Its control pad can also be removed to double as a wired remote, if you have the wire. But I don't, and they are really hard to find secondhand. But that remote function can exist because it's also an early full logic control deck with a built-in microprocessor. These features together mean this was a pretty high-end and advanced deck for its day, and that's a big reason why I feel like it's one worth preserving. It's got 2 heads for each direction and 2 brushless and slotless motors. Decks with 2 motors have one for the capstan, aka the main drive, and one for fast forward and rewind. Its shared playback and record head is a ferrite and ferrite design. That means it uses ferrite for both the core and guard. It's supposed to be a very robust and long-lasting design, though that durability comes at the expense of some high-end frequency response. Indeed, mine looks in really good shape. So I don't think the head is responsible for the record and playback issues this deck has. It's got switches for tape bias, selectable between low, normal, and high, and EQ, selectable for normal ferric oxide, ferrochrome, or chrome tapes. Ferrochrome was type 3, which only lasted for a few years on the market, so you do need to be a little careful to not just leave this lever set in the middle. No metal tape support on this machine. Those didn't exist in 1978. The last lever is for Dolby, and they just called it Dolby in those days, not Dolby B, since it was the only one on the consumer market. You can select between off, on, or on with the filter off. The filter is an MPX filter for recording from the radio, which otherwise could record the 19 kHz pilot and 38 kHz subcarrier frequencies, or their harmonics. When recording from sources other than the radio, you would either leave this switch off or in the on but filter off position. Of course, you see those giant VU meters, which were uncommonly large and were a selling point even back in the day. For a brief time, there were decks with analog VU meters on sale at the same time as decks with digital meters. Obviously, digital won out because it looked newer, but I much prefer the real analog VU meters like this. On the left side, you may notice the knob labeled Headphones and Line Out. That controls both the headphone jack volume and the variable line out, since this deck has both fixed and variable line out jacks on the back. Again, I've tried both, and I get the same distortion. So I admit to having cheated just a little bit with this thing. A couple nights ago, I hooked it up just to see if it was going to be even worth making this video. And I turned it on, kind of watched it come back to life, which was really interesting because that's exactly what happened. When I first turned it on, even all the lights were really dim. And, I pressed some of the buttons, nothing was happening. I could kind of hear the motor running, but put in a tape, and then gradually it started just working. And now it fast forwards, rewinds, plays both ways. So basically, it is working. I'm pretty sure I changed the belts on it a long time ago when I first had it open. I changed some transistors. It still has this weird problem where it's just much, much louder in one channel to the point of distortion. And I'm sure it also needs just a basic service, cleaning, and I'll check the belts again, and pinch rollers, stuff like that. But I'm going to do all this with the help of my brand new Finercy 2C53T. This is a fun little device, and this kind of thing just did not exist when I first started working on this kind of stuff. And if it did, I would have done this a lot earlier. This is a combination oscilloscope multimeter, handheld, and importantly, a signal generator, which also is really going to help here. And you can have the signal generator working at the same time as the oscilloscope. So it can generate a signal, and I can measure that same signal as it goes in and out of the tape deck. It's going to be perfectly fine for working on any audio and even vintage computing. And $75. I mean, I'll put a link to this. Well, I paid $75 with a coupon and other stuff, but normally I think these are like $99 on Amazon. I'll put a link in the description. I thought about just making a video about this itself at some point, but there are other videos out there, and I don't know enough about this stuff to really make a good video. But yeah, this is a really cool, fun, helpful little device, and I would recommend buying one if you're into this as a hobby, as I am. Anyway, so let's just see what this thing is doing. I'll just put in a tape, and we can see what it does. So here's rewind, fast forward. I hesitated to do this last night. This tape does have stuff on it. This is the tape that I recorded for my cassette, or actually for my mini disc video. So it has a lot of different stuff that I recorded myself on a known good deck. And there it is playing. VU meters are working. Here's what it looks like on the little scope. If you can see that, it's not telling you much without having a proper signal wave going through there, but we'll do that in a minute. So I've got it on the signal generator here. I've already got this set up, and it's running. I've got a 1 hertz which is the default. It doesn't really matter. 1 hertz frequency and 0.8 volts. As soon as I hit record, you're going to see it. So there we go. You see the VU meters, they're now zeroed out, as if that, you know, it's seeing that, and that's what it's going to record if I start recording. And this is measuring what's coming out of the tape deck. So I have the signal generator going into the input of the tape deck, and it's in stereo. I've got a Y adapter on this. So not stereo, it's mono in 2 channels, but it's the same signal in both channels. And then these are coming out from the line out, the fixed line out. So this is actually reading the output from the tape deck, not just the output from itself. And it looks fine. For now, let's just try recording this and see what happens. It should be able to record this and then play it back and have it look pretty much the same. Kind of doubt that's going to happen, but let's see what happens. So I've turned the tape over so there's no music on this side. And I'm just going to zero out the tape counter. And then let's start recording. Okay, so I've recorded a few seconds. I've reset, well, not reset the tape counter. I've rewound to 0. And let's just start it now and see what we've got. What it's reading on here now is going to be what's actually on the tape, or what it's reading from the tape. And that does not look good. Yeah, so it's not recording well. I'm just going to go through, I'm going to clean everything first, and then I'm going to try this again. What's on? All right, I don't know if you can see that if the camera's in focus. A little bit of dirt came off. No, it looks no different to me. It's possible there's some kind of alignment issue, or the azimuth is way off. I'll be checking that as well. You know what? Before I even do that, I think I'm going to try recording on the other side of the tape using the auto reverse mechanism. If it is an alignment thing, it's possible it could be aligned in one direction but not the other. So let me just try that before I before I do anything else. But yeah, we're going in that direction now. Okay, get back up to 0, and we'll go backwards and see what it got. And no, same thing. I downloaded a bunch of tracks from the YouTube audio library so as not to run afoul of YouTube's content ID, and I recorded them to my Techniques deck that I know works well. I played them back and they sounded just fine. I recorded that same sine wave to the Techniques deck just to prove to myself that it was working as good as I thought it was, and here it is playing back. It's pretty much perfect, not bad for a deck this old. I took that same tape, played it on the Sony deck, and captured that in my PC using Audacity. And let's take a look at the results. So I actually recorded about half an hour of music on here, about 10 different tracks, I think, plus a couple of sine waves at the end that I'll talk about in a minute. But you can really see what's going on here just in the very first track at the very beginning. So I'll play you that now. Just keep in mind also that this deck is running a little bit fast, so you're going to hear a little bit of a difference in pitch. That's probably an easy adjustment. I'm not worried about that. But I want to just have you hear what it sounds like right now. And hopefully you'll be able to hear the distortion that I'm talking about. I can hear it clearly, and you can see it in the waveform as well. I'll play you the original first, just so you hear what this is supposed to sound like. right, that's honestly enough. You're gonna hear the difference. Listen, especially on the downbeats, you'll hear the distortion. It's a little less obvious in the kind of louder parts of the song. That was the original again. Now I'll play you what's on the tape. Clearly lower fidelity, but it is a normal bias tape and it's a tape. So, but the point is the distortion itself is masked a little bit. It's a little more obvious in the quieter stages. And I actually got a lot of piano music intentionally because it's easier to hear any wow and flutter that way. It's not really what I'm testing for right here. But anyway, that distortion, if you notice here, these waveforms don't look the same. The top of the waveform on that left channel is cut off. And if we scroll over and look at the sine wave, this is my 1 kilohertz sine wave that the Techniques deck was playing back perfectly. This is the same tape again, remember? And you see that the top of the left channel is cut off. That's distortion. So hopefully that's just an adjustment I can make. I mean, there's a couple things that seem to be electronically wrong here. This deck is not recording well at all. And it's playing back with this distortion, even on well-recorded tapes. The last thing that I want to show you is the wow and flutter. For the wow and flutter, I used a test tape that I bought off eBay. I don't know how good it is. It was recorded on a deck with quartz lock speed control. So hopefully it's pretty good, but again, it's probably not perfect. But anyway, here is the wow and flutter tested with WFGUI. This is measuring to the DIN standard, and you see it's peaking at probably somewhere 0.2, a little more than that, but RMS, it's about 0.11 to 0.14 or so. And if we look at the service manual, most of the time manufacturers will publish these specs in a way that looks best for them. But in this case, Sony actually published the wow and flutter 2 different ways. So 0.05% to the NAB standard, but also they list the DIN standard, which is what WFGUI is using, and it says plus or minus 0.14%. So from what I can tell, it's within spec as far as wow and flutter. And honestly, in the piano music that I recorded, I didn't hear much wow and flutter. So I think it's doing as well as it can. I'll see if I can make it any better, but I probably can't. So those are probably all the tests I can do from the outside. Now I'm going to open it up and just see if I can figure out what's going on the inside. Okay, well, I'm going to go ahead and start taking this thing apart. Some of you may be wondering why I have not done an azimuth test as of yet. And it's just, actually I just haven't shown it on camera, but it's just, it's one of those things where you really want the mechanism to be working at its best before you do that. So I'm going to take this thing apart. I'm going to just look at the mechanism. I don't think there's really much I need to do, but I just want to make sure it's all nicely lubed up as well as I can, and nothing looks cracked or anything like that. In case you're wondering if these are real wood, How nice is that, to have a faceplate that comes off without even having to remove the knobs? It's definitely essentially out. Okay, I have to snip some cable ties down here if I can even get to them. Alrighty. Boy, this thing is really wedged in there.
Thousand years later.
Okay. Oh, I've got this footage if I need to figure out where things go. Bridge those two, I'll worry about that later. Well, there's the mech, and it's quite chunky. I don't see a lot of plastic in there. Well, yeah, I mean, there's some, but yeah, big heavy metal flywheels, and like I said, I don't know how much I really need to do here. I'm just checking to make sure that everything is kind of spinning freely and that the belts are okay. Now that I look at this again, this feels like an older belt. I am going to order some new belts again for this. And I bought some before and I may just not have ever put them in. Or maybe this is them. That was almost 10 years ago. I've got one spindle apart and I'm just going to lubricate it a little bit. I feel like this is the only part that's not spinning completely freely, so I'm just going to lubricate the bushing just a tiny bit. A little bit of oil on there. I just want to say I wasn't actually happy with this, even though this is plastic safe oil. It's not the 3-in-1 you see in the background. It's actually oil for model railroad wheels. But I went back, I cleaned this all out, and I ended up replacing it with grease. And get it over the brake. Yeah, that feels better. Okay, get this one put together, and then I'll do the same on the other side. Oh, these C-clips. Where'd it go? Tiny little C-clip. That's what we're dealing with here. So I got this hub put back together fine, but when I went to take the other one apart, of course, the C-clip, or E-clip technically, went flying across the room, as they often do. And I got down on my hands and knees, could not find that thing. Ended up ordering a whole bunch more. Took the time, since I was going to have to wait anyway, to order the belts. All right, well, it's about a week later now, and I'm back with the new belts, so I'm going to replace those today. Also got some new E-clips, or C-clips, And I even ordered another mechanism. As you can see, it's not the same mechanism. This is the mechanism from a TC-K1A, but it does share some of the same parts. And I realized as I was doing this that I could use a few extra spare parts, like the little spindle covers and stuff here. So just in case I need those, I got this. It is interesting, though, to compare these. These decks were made the same year, from as far as I know, and just look at how much more metal there is in the TC-K96R than there was in the TC-K1A. This mechanism, plastic, I don't know what you call that, back plate, there's just a lot more plastic in this TC-K1A. The 96R, I don't know, I guess it was a much higher end deck, but it just, there's a lot of metal, chunky flywheels. The flywheels in this TC-K1A are, I can barely even see one down there, but they're a lot smaller and just one motor, and it's not as good of a motor. So quite a big difference in the mechanism, despite outwardly these decks not looking that much different, but they were. Anyway, I'm going to get to replacing the belts in the 96R deck right now. Now that I have it out, it actually feels fine. I'm going to replace it anyway, but because it's still about 10 years old, but I think I did put that in myself. Here's the new belt versus the old belt. Not sure the best way to do this, but that's looking good. That's the drive belt done. Just got to do the tape counter. Already got this all undone, so just need to pull off the hub. It gives me access to this belt. Alright, I'm trying to do this without taking the whole thing apart, because I think it's stupid to do that when you don't have to, but I need to make a plan. I have this little tool with the hook. I don't even know what this is actually for, but I have a feeling this is going to save me. Yeah. Okay. Now the hard part, the C-clip or E-clip. Okay. Hopefully this does not go flying again, as I've had happen several times now. Might be a little hard to see, but yeah, it's in there. Okay, should be on there. That's done. That's the belt replaced, and you know, I think that's pretty much all I need to do to the mechanism. So I've cleaned the entire thing, including the idler tire, the brakes. I've replaced the belts. I've lubricated the, I don't know what you call these, the spindles. Yeah, I think this mechanism should be in pretty good working order now. All right, let's get this thing back into the machine, hopefully. Oh, that was an ordeal, but I think I pretty much have it. Now to figure out again how to screw it in and where all the plugs go. Oh, that makes it easier. I assume that goes there. Alright, let me screw the board back in and then I'll solder those wires back in. Hopefully I know what I'm doing here as far as where these go. Alright, well, this is what it's doing right now, and I'm pretty sure I know why, but if you notice, this is the tape that has some music on it, no VU activity, so it's not reading or not outputting what's on the tape. Okay, well, I'm kind of hand holding the camera here, so hopefully this is going to be easy enough to see, but one of the head wires came undone, the blue one here, so I'm going to restrip that and just try to resolder it and see what happens then. It may not be the whole problem, but it's definitely something I need to fix. So I'll get on that. Tiny wire is reconnected and it seems fairly solid. Alright, this thing has been eating tapes again, so I gotta watch that, but here we go. And still no output. I later realized that due to the design of this deck, there wouldn't be output in this situation the way I have the mechanism out and on top of the deck here. But I didn't know that at the time. Anyway, there is something else going on here. I'll have to start poking around. One thing I did notice is that there are some really bad solder joints on this board, so I'm going to just fix a few of those, as many as I can see right now. Again, probably not the actual problem, but something I should fix anyway, so I'm just going to get to that. So I was poking around a little bit last night, and it seems to me that the audio amp board is just not getting any power right now, which hopefully that's just a simple thing. This brown wire is what carries the voltage to the audio amp board. That's connected to a little just 3-pin connector. It looks like the wire's just wrapped around it. It seems pretty secure. I'm just going to, I don't know, I'll reflow the solder. I'm going to test that also. I can measure the voltage at that point on the back of the board. And yeah, I'll see if that has anything to do with anything. I will say that I've checked all my plug connections and everything looks good as far as I can tell. I pulled them all out, put them all back in. I didn't miss any. None of them are backwards. They were all snapped in. So I don't think it's that, but it still could be a broken solder joint or something like that. Okay, so I'm going to turn it on and just check the system board where that brown wire is. So this should be the brown wire. "36 volts, 35 volts. That's pretty close to what it's supposed to be. This wire also goes to the board. 7 volts. That looks probably correct. And then this other wire is ground. And that is. So at least those 3 wires at the system board look fine. All right, it's turned off right now. The brown wire comes in right here. Yeah, I'm going to turn it on, and this should be 33 volts. And it's not. Okay, well, I've learned something, which is that the service manual is wrong. And this is something that occasionally does happen. I don't know how much of this you can actually see. The service manual shows that brown wire coming in over here, which is what I tested before. I'm going to turn this on again. So right here actually is where the service manual shows that brown wire coming in. Sorry, this is out of frame. Here's a better look at it. This is where that brown wire is supposed to be coming in. It's actually coming in on the other side of the board. This other brown wire here is supposed to be there, but it's a different brown wire, but this ends up being what is actually carrying the power from one side of the board to the other. So I figured out, it seems like the wire from the main power supply is coming in over here. It's then going back out, coming back in over here, and then there's a bunch of components designed to turn this 36 watts. It's really supposed to be 33 volts. Various components to turn that into 22 volts, which then gets split out around the board and used by various other components. So I've gone through, the service manual does helpfully tell you what voltage everything is supposed to be. So this thing is on right now, and I've got where it's coming in, I've got 36. Down here, Q510, it had 0 on this pin, which is supposed to be 22. It's got 36 on this pin, and it's got 36 on this pin, which, from what I can tell in the service manual, are not supposed to have anything. Q511, similar thing. Whoop, supposed to be 22 here. We got 0. Okay, then down here, this is supposed to be 23.5. That's 36. So it hasn't been reduced. Down here, we're supposed to have 22 volts. I'm not exactly sure. I think it's this one right here. And that's nothing, just to make sure. These others, nothing. And then it goes across. It's supposed to be 22 volts here as well, and that's nothing. It's just this DC power supply, somehow the power is not getting out of it. And it sure seems like these transistors up at the top are not doing their jobs. Well, I'm just going to remove all those transistors in that area. It's turning into a bigger repair than I planned, but you know, sometimes that happens. And by the way, I had reflowed all of them before, so it didn't work. I am definitely going to lose track of what screw goes where at some point. This is really maxing out my work area. Okay. Let's see if I can get these parts out. I know, I'm no Mend It Mark with the way I'm filming. He has multiple cameras. My iPhone is charging. That's what I've been using for my overhead shots. Okay. Okay, well, surprisingly, I think I'm actually on the right track. I removed all the transistors, not all, I mean the 4 from the power board. or the power side of the audio board. And I've tried measuring them just with a multimeter, to basically see if they're definitely bad. This is the base to the emitter. So still getting out of limits. Base to collector, 0.003 volts. Collector to emitter, out of limits. Emitter to collector, out of limits. Collector to base, 0.003 volts. What have I not done here? Maybe that's it. But that is not normal. So 99% sure this is a bad transistor. So need to replace that. Just for comparison, here is one of the other transistors I took out. I think these are all okay. But so 0.7 volts there, that's normal. 0.7. I'm trying to use a piece of tape to hold it steady, but it's not working too well. 0.7. I mean, when it kind of relaxes a little, it's on 0.7 there. Certain combinations are supposed to give you an open or an out of limits, and they do. But you're supposed to get a voltage between 0.4 and about 0.8 or 0.9 when it's working on certain combinations of legs, depending on if it's an NPN or PNP transistor. I don't remember what these are, but that's what it should look like. And you saw how on this one, it was not anything close to that. Bottom line, I may just put these ones back in. I'll kind of see if I can easily find some direct replacements. These are old transistors at this point, and they're not made anymore. So you got to find ones that are kind of close, and whoops. Sometimes that's hard to do. While I wait for the new transistors to arrive, I figured I'd do some basic maintenance tasks that I would need to do anyway. So first I demagnetized the heads using a head demagnetizer. And then I went ahead and cleaned the pots and switches with some contact cleaner to get rid of any scratchiness that they might have. And lastly, I decided I should tackle this scratch that I made in the left side wood panel when I was last working on this thing. Yeah, I made this scratch. It wasn't there before. I went out and bought some of these wood touch-up markers from Home Depot. And the goal here isn't to make the scratch completely disappear, because that's not really possible, but just to make it a lot less noticeable. And I think I accomplished that. Okay, well, the new transistors have arrived, and I've tested both of them. I've got new K30A GRs and a replacement for the C1173. And these ones, this is the K30A, these are testing pretty much the same as the old ones. So, but now we've got the 1173, and this one, remember, I don't have tape under this. This one just shows basically nothing. It's like 0.003 on a couple of them. This one, these are both NPN transistors. This one, there you go. Got a reading. I mean, the other two, you know, this is how it's supposed to be. But so, yeah, this definitely, this transistor's dead. This is hopefully the whole problem with the power board, and hopefully that'll fix it. Not exactly the same transistor. I've looked it up. Again, you know, it's possible I'm just a complete idiot, but this is the replacement. Motorola lists on their equivalent sheet, so hopefully it'll work, but, you know, I don't know. You know what? I'm going to put just a tiny little bit of thermal compound on this. It's probably not really necessary, but I do think these things get a little warm. Gonna make a mess, of course. Of course, this is the one screw that's not a Phillips, so it's just sliding around all over the place. By the way, guys, I like my Radio Shack solder, and I use it whenever I can. I have other solder, and people have called me out on this before, but this stuff works better than anything else I have. So it's just easy to work with. And when I run out of it, I don't know what I'm going to do. I'm going to have to find something like it again. But anyway, I'll get these transistors in here now. All right, those are solid. Let's see what happens. All right, well, I won't keep you in suspense. I already tested this out. Here we go. We've got levels. It's playing. Okay, yeah, this is not a scientific test. This is just a pre-recorded tape that I know has music on it. And it is playing. I guess I should test the actual voltages against what the service manual says. This is supposed to be 22 volts. That can't be right. I don't know how to make it so you can see this while I can also work here. Huh. That's bizarre. Is it only when there's a tape playing? Oh no, did it die again? Okay, well, it was working. You saw that. It worked for about 5 minutes and then it stopped. I have a couple theories on what's going on. First of all, I do think I'm on the right track. I think somehow the audio amp board is not getting the kind of power that it needs, whether that's because of the system board, which is what's actually sending the power to the audio amp board, or the little power supply area in the audio amp board itself. So the two theories that I have are, first, that it is still actually the transistors, whether I got some bad ones or maybe the ones I got just aren't compatible. I'm going to interrupt myself here because, yeah, that was it, and there's no point wasting more time on this. My second thought had been that it was the power itself, and I went on kind of a wild goose chase tracing back to where the power was disappearing. For a minute, it seemed like it was all the way back at the bridge rectifier, which is literally the first component on the system board after the transformer. There was no DC voltage coming out of it at all. I removed and tested that, though, and it was fine. I even then measured the waveform coming out of the transformer, and it looked super weird, so I thought I might have a bad transformer. But in the end, I just ordered some used but working 2SC1173 transistors like the one originally in this thing, and that fixed the power problem. Here's my signal generator pumping a sine wave through the input and back out again like before. I don't really know why my replacement transistor didn't work. Part of the problem is that they seemed to just measure stuff differently 45 years ago, so it's hard to directly compare data sheets. But my component tester does tell me there's a large difference in HFE between these two transistors, so I'm guessing it's that. To be clear, the original 2SC1173 that was in this machine at the beginning is still dead. It's not a resistor. That was a real issue. But my supposed equivalent transistor didn't work. What worked was another 2SC1173. But the saga is not over. I'm still getting no output from tape. I can hear some white noise when the head is engaged, and I can measure it at all the points I should be able to on the board, so the amp is definitely working. That at least narrows it down for me to either the head itself or something mechanical. It's probably something I did, since I was getting output before, which hopefully means it's also a simple fix. I still need to do all the actual adjustments, but I've been doing maintenance stuff along the way, and this is hopefully the last of the actual repairs. But we'll see. Okay, well, I just off camera had one of those what if moments, and I tried something and I got at least some kind of a result. Watch this. And this would not have been possible until I fixed the audio amp board, but watch this. I'm in play. I've got my sine wave going in, and it's reading the sine wave coming out. It's stuck in record mode. It thinks it's in record mode. That's why I'm not getting playback. I'm not sure how to fix that with this deck, but it should be fairly simple. I just need to figure it out. So check this out, just a quick clip before I quit for the day. This is the record and play switch here. There's a lever here, if you can see it, that is supposed to engage it when you press play. And I can just show you here. It's not actually, it's moving the lever, but it's not actually moving the switch. And we've got nothing on the VU meters. But if I just manually take it, look at that. Look at those VU meters dancing around. So that's it. I just need to figure out, it's something mechanical. I don't know why it's not pulling that lever enough to flick that switch, but I'll figure that out hopefully tomorrow, and then I hopefully can be done with this thing. All right, well, this had me stumped for about a day, completely stumped. I took the mechanism out, I was looking at it, took it all apart again, and could not figure out, why this lever was not pulling this switch all the way over. Then I just started messing around with this switch, and the truth of what's happening is even dumber. If you can see this part here, I was looking at this, I was like, that looks kind of odd. I don't know if you can see on camera there. It's kind of pushed up against this little component. I was like, that can't be right. And it's not. This has just come misaligned. It's supposed to be kind of like that, I think. And when it's like that, it won't go back any further than that, and it's much easier. There we go. See, but it comes off. So I got to figure out why that's happening. It might not happen when the mechanism's actually in there. There we go. That's how it's supposed to be. And hopefully that'll fix it. As long as I have the mechanism out, I'm going to hit it with some rubber renew on the rubber parts, the idler tire, the pinch rollers, things like that. The rubber has gotten a little hard. I've used this stuff before. I've had good luck with it. It just makes it a little more softer and a little more grabby. All right, well, it's all back together. I didn't show that because I've shown it before, but moment of truth. We have activity. This thing is playing again. Now to measure and make those adjustments. First, let's just see how it's doing compared to how it was when I first tested it out for you guys. So here's the oscilloscope again, and I've got it queued up to that same waveform that I recorded earlier. So let's see. So the tops of the left channel are still being cut off, and that's not unexpected, but it does look like it's playing a little better to me. If you remember that waveform was just kind of all over the place in terms of speed and all that. This is definitely more stable. So I'm at least at the point now where I've got it better than it was. Well, I hope you've enjoyed part one. At least it's working again, and it's working a little better than it did when I started. Stick around for part two, or click on it somewhere. I'll put it at the end card, and it'll be down in the description. If it's not there yet, that just means I'm still working on it. So come back. sign up, subscribe, whatever. Get that notification bell thing going so you see when it's posted. And yeah, check it out. Hopefully I can finish this up in part 2. It's going to be a wild ride.